Welcome to a new video from IFS Mastery Path. This is Mo, and I'm glad to be your presenter today. This video belongs to a series of videos where we're going to be discussing the data that we receive on a daily basis in the construction realm and how we can transform the data into a more enhanced format that is easy to analyze and process. In today's video, we're going to be exploring how we can transform a hierarchy into a database. Our video today is going to be composed of three parts. The first part is a problem statement. The second part is methods to think about the solution. The third part is going to be implementing the solution. In today's video, we're going to be making the best use of if statement, ifs, and switch functions in Excel. And now, without further ado, let's get started. So now let's start with the first part of this video, which is understanding the problem at hand. So people working in the construction industry, they face day in day out cost data, which is presented in a hierarchy format, as you could see in the screen. The hierarchy format is all about parent levels and children levels. And the end goal of this task is to convert that hierarchy into a database format like this. So we have the item descriptions of these levels into 4 different columns, which can then be summarized into a pivot table. And now let's think how we can sort out this problem. Let's start with the second part of this video, which is understanding or thinking about how we can sort out this problem. So this problem, in order to be sorted out, we need to understand what are the header levels of each and every single row that is existing in the current dataset. And then the second logical step would be splitting the rows in the dataset into NRM different levels, because the maximum level that I do have here is level 4, and that's based on my understanding of NRM 1. And once we undertake these 2 steps, we then need to be filling down, and that's what we're going to be looking at. And now let's dive into the solution. And now let's start with part 3 of this video, which is the actual solution. So the first part of the solution would be the understanding of these header levels, and that one is quite easy to undertake. Based on understanding the data that we do possess, if you don't have any dots, then the row represents level 1. If you have only 1 dot, then the row represents level 2. If you have only 2 dots, then the row represents level 3. And then if you have 3 dots, then the row denotes level 4. We don't have any further levels, and again, that's just based on this use case. So let's start with the solution. Let me put the solution into an if error first, and then if the length of this cell minus the length of the cell without any dot. So to do that, we're going to be using substitute. So we're going to be substituting in this text. The old text is the dot, the new text is nothing, and that's it. So if the length is equal to 0, then level 1. Let me do it easily for us. So let me press Alt Enter, and if false, then let's go to the second condition, which is level 2. So let me copy that. So if the difference between these two is 1, then it's level 2. And if the difference between these two is 2, which means that there are 2 dots, then it's level 3, and then otherwise it's level 4. Let me close the brackets. So that's the bracket for the last if, a bracket for the if before it, a bracket for the second if, and what happens if there's an error, just put nothing. Let's see the formula again. In any case of error, give nothing, and then the main body of the formula is if the length of the cell minus the length of the same cell with the substitution of the dot to be nothing is 0, then it's level 1. If that process or that operation of subtraction is giving 1, then that's level 2. If the result of the subtraction is giving 2, then that's level 3. Otherwise, it's level 4. Now let's drag it down. So let me go to the last cell by pressing Ctrl and down. And then here I'm going to be pressing Ctrl Shift up. So that's done and dusted. That's the first part of the solution, understanding the header levels. Having understood what are the header levels, as we have done previously in the previous step, we now need to split each level separately in a separate column. So that's what we're going to do. The solution is quite simple. So if that cell is equal to 1, then give me the actual row. Otherwise, give me nothing. Let's jump to row number 2. We can take the same formula here and change it to 2 if you want. However, I don't really suggest that. There is another way which is quite automatic and it's going to enable us to do stuff very easily. Here, what I can do is I will say if everything in here is equal to the value of the right of that one here. So the last character from the right, which is E1 and 1. Let me fix the row here, and also for these columns let me fix the C so that when we do the copying and pasting there's no problem. So if the whole range is equal to the value of the first character from the right in E1 here, then give me everything here. So as you can see here, it gives everything accordingly, which is pretty decent, and the formula now could be copied and pasted very rapidly. As you can see here, now everything is split out, as you can see here, and that's exactly what we want. We want to split the header levels into different levels. And now there is one last piece of this puzzle, which is filling down one substructure until here, substructure, and here until here as well, and so on and so forth. And then in each and every single subsequent level, it has to make sure that it's filling down correctly. Because for argument's sake, there's a space here. We don't want the basement to be filled down until here. We want it to stop until here. So we're going to be seeing now how we can do it in the last part of the solution. The last piece of the puzzle is how we can fill down correctly, taking into account the difference between the levels on level 1, 2, 3 and 4. So let's start with level 1. There's something that is really interesting here in that data structure, which is row 2 is always blank for levels 2, 3 and 4, and we can use this feature when we are drafting the formulae. So let's start here. So we can say if that cell here on level 1 is not equal to blank, which means that it contains a value, then give me its value. And if otherwise, then we're going to be checking if the current row is equal to 2, then give me nothing. Otherwise, give me the value of what's above. And I'll explain this in a little bit. So let's drag down here until the last row. Let's analyze, for instance, row number 8 here. It evaluates if E8 contains something, then give me its value. Otherwise, check what is the row number. So the row number here is number 8. So it's not 2, so it's going to give blank. Otherwise, it's going to give the value of the cell above it. The next level here, so levels 2, 3 and 4, there's a little bit of a condition that needs also to be met. Have a look at these two. If the cells are not the same, then give me a blank. If the cells are the same, then you can continue filling down. And that's going to be the logic that we're going to be doing here for these levels. We're going to be continuing from the same way of thinking. So if NRM on level 2 is not equal to blank, then give me that one. Otherwise, we're going to be checking if each two consecutive cells in column K are equal or not. I'm going to be saying if that one here is not equal to the one above it, if these two aren't equal, which means that there's a difference level, so return blank. Otherwise, we're going to be checking the row again. So row, if the row is equal to 2, then give me nothing. Otherwise, give me the cell above it. Let's close the third if, let's close now the second if, let's close the first if. And now let's drag down. And it works perfectly fine. Let's check manually. We need to fill 1.1 up until here, which is exactly what we've done here. And then number 2 or level 2, it will have always a blank in here, and then it's going to start from here, which is row number 13 up until row number 19 with 2.1, and then 2.2 starting from row 20 until row 23, and so on and so forth. Let's do the same in here. So the logic is quite similar. The only thing that we're going to be changing is column L instead of column K. So let's do it again here. So if NRM on level 3 is not equal to or contains something, then give it to us. Otherwise, we're going to be checking if that one is not equal to the one before it, then give us a blank. Otherwise, you're going to be checking if row is equal to 2, then give us nothing. Otherwise, give us the cell before it. 3 brackets, and we can do it here on level 4 as well, just copying and pasting. Everything now is done and intact. And now you can see that the hierarchy has successfully been transformed into a database. And to showcase this, we can select these or this range, and then we can go to the insert up top and then a pivot table from table range, and then we're going to be choosing the existing worksheet for the pivot table. Let's put it here, and then we can put the NRM1 levels in the rows. And then there's something that we need to do. In NRM level 2 you will find a lot of them blanks. Level 3 as well, you need to disable them so that you have a much better summary. As you can see here, everything's done and dusted. So we started with the hierarchy structure. We managed to split the different header levels into different columns, and then we managed to convert them into database. They can easily be summarized. You can keep in mind that this is also applicable for BOQs, complete BOQs, descriptions of activities and the whatnots. You can also think about time programs. We can also do things in a different way, using the same methodology of thinking, but using different formulae. So instead of if, and then if, and then if, nested ifs, which is a bit harsh for some people, we can use a function called switch. So switch is the same like if, but you can put lots of them conditions. So we're going to be writing the same exact syntax that we have done here, but using switch. So let's take a copy of the formula here, and then let me put it, and instead of if here, I'm going to be putting switch. To switch, you have to put an expression at the beginning. We always use true, and then you continue the formula. We have the actual value 1, result 1, and then, or the condition, what happens when true, and then the other condition, we're just going to be deleting that if, the other condition, and then what happens when true, and then the last value or entry is going to be what happens when there is false. And then when you press enter, you will find the same exact result that we have achieved here. Let's do the same for the rest of the formulae. We take it here, we copy it over, and then replace if with a switch, and then the first argument is going to be true. The first condition, what happens value if true, that's the second condition, and then the value if true. Third condition, what is the value if true, and then the last value if false. Let's drag these two now down. As you can see, it works perfectly fine. We can complete the remaining. It works perfectly fine. It's exactly the same. As you can see here, you can see the results. It's exactly the same. Everything's intact using switch or if, depending on what you're after. I would say that if is traditional formula that is understood by a wide variety of people. Switch is understood more by people working in Power BI, writing a lot of DAX. And here you go. That's how you can transform a hierarchy into a database structure using two methods. Another method that we can use as well, instead of nested ifs. So as you know, we have explored nested ifs and we have explored switch. There's a third method where we can use ifs, which basically evaluates lots of conditions. So let's take a copy of the formula that we have drafted in here. Just copy that formula here. So ifs, the way it works is, what is the condition? What is the value of true? What is the condition? What is the value of true? Ifs, it doesn't have a value of false. So as you can see here, it's always logical test value, logical test value, logical test value, and so on and so forth. So in order to give a false condition, or the value if false, before the value that you want, you can put true, and that's going to be the last condition to be evaluated, and then comma, and then the value if false, which is basically the value of true, because true is always going to be true, and then the value of true, which is that one. And this last condition is basically what we're saying is, if nothing else is working, then that's the last value for the false condition, and you'll find that it works perfectly fine, exactly as we've done here with the switch. Let's copy out the formulae and replace the syntax. So instead of the switch, let's put ifs, remove the first true, and before the last value we can put a comma and then true. And let's repeat it again with level 3, and the last one is NRM level 4, and then let's copy these three down. That's done. The same exact result. So as you could see here on the screen, you have three different ways to do it, using either nested ifs, which is understood by a wider audience of those who are using Microsoft Excel, switch, and ifs. Thanks a lot for watching. Hope you found this video useful and insightful. I've prepared a couple of them other videos about fine-tuning large language models and deploying them to OpenWeb UI. I'm going to be putting the links in the description below. You can also pay my website a visit at www.apcmasterypath.co.uk, where I provide multiple packages for the RSS APC candidates to support them throughout their RICS journey. Also, I provide lots of insights about the RSS APC process, the different areas of competence, and how you can deploy AI within the construction industry. Do not forget to hit the like button and subscribe so that you get notified about our latest videos.